Good morning, it's day 2 of Embedded World and I'm joined by Chris Gammell, Developer Relations Lead of Golioth. Chris, thanks for joining us today.
Good to be back.
And how about we begin at the beginning?
Yes.
What is Golioth?
So Golioth is an IoT platform for building devices and getting your data to the cloud and getting data back and forth from the cloud, but also over-the-air updates back down to your devices. That's basically a full device management solution as well as data routing. Okay,
excellent. And how would a hardware or firmware engineer use Golioth in their own designs?
Well, it helps that I'm a hardware engineer. So the way I do it, basically I usually start from existing hardware. So using things like dev boards and buying off DigiKey. I will usually use something like Zephyr, which is a real-time operating system. And then I will pull in the Golioth SDK, which is basically a communications module that goes into a lot of different real-time operating systems like Zephyr. It's not just Zephyr, it's also FreeRTOS and other ecosystems. But I'll pull that stuff in there. We have great support for developers using different types of firmware. And then I will use a lot of the examples, including some of the reference design stuff I'll show here. And usually I'd start then sending data back and forth from the cloud. So things like sending sensor data up to the cloud, right? We'll be showing a lot of that. Or pushing sensor data from the pushing settings from the cloud back down to the device. So things like, I want this LED to be blue or red, or more complicated things like, I need you to take readings every 15 seconds instead of every 20 seconds. And so there's a wide range of different services and capabilities that Golioth enables, and really we smooth out the in-between parts so you don't have to be thinking about what connectivity mechanism you're working with. It's more just about the application space and focusing on what you want to be actually building.
Okay, fantastic. And can you provide an overview of Golioth's journey into developing reference designs for IoT subsystems, and what inspired this new decision to open source the underlying board?
Sure, yeah. So let's start with the open source thing first. So open source was because we started from open source. So prior version, so I'm holding this mess of cables in my hand, but I'll talk about it a little bit more. We started from a lot of open source boards, so things like NRF 9160 Feather. So that's a cellular board built by someone, Jared Wolf, and he open sourced that, and then we used that design and kind of extended it and added some more sensors and some more features that are more specific to this form factor. And so then we said, okay, we're going to open source this as well. And so that's, as of Embedded World right now, we haven't open sourced it, but we'll be open sourcing it next month. And so some of the journey around reference design generally is basically, we have a lot of customers. So IoT is this big, broad field, right? You have cloud, you have firmware, you have hardware, you have the people that are actually using the end product. And so how do you piece that all together? You have to have some end-to-end example showing it all the way through, because if you just show the one piece, if you just show the hardware piece, then the cloud person's like, I don't know. If you just show the cloud piece, the hardware person's like, And so you have to have some way to actually run through the entire path. And once you have that, though, then you could start to not just you can talk to teams instead of individuals. And you could start to say, hey, look at this thing. And hopefully they say, yeah, that's cool. And then you say, what do you like about this? And they say, oh, the hardware. Oh, let's talk about hardware. Or, hey, the cloud. Oh, let's talk about the cloud. And so having these end-to-end demos really allows you to drive the conversation whichever way you want to go. So which way would you like to go, Kristian?
Well,
cloud, hardware, firmware?
Well, next I'd like to go into Golioth a bit more.
Golioth. Okay, so it's cloud. Yeah, sure.
So the primary objectives Golioth aims to achieve, what are the primary objectives it aims to achieve with the open source approach to IoT development?
We're just kind of all coming from the open source space, and IoT is kind of this mishmash of different standards and different services and different providers. And we figure being open is the best way because it lets people peek under the hood, build more confidence. One of the big things is a lot of people that have come into the IoT space have been like, I don't trust anyone. I'll just build it myself, right? I'll just build it myself is kind of the tough part of IoT because it's kind of the default and it is the most treacherous. And so we're hoping that having some more open source stuff, people look at it, they say, oh, okay, I believe in this. If I really needed to, I could always, pull the ripcord and go do it myself. But it's kind of just building confidence into other people's systems, in this case is Golioth. And there's other great providers that are also doing open source. So more of that ethos kind of helps to build confidence in the entire industry, I feel like.
Okay, fantastic. And you have your Modbus vibration monitor with you.
I do.
Of course. Can you tell us how it stands out among other reference designs, and what specific needs does it address in the IoT ecosystem?
Sure. So, as I'm sure your biggest fans will be watching last year, this box looks very similar to last year. I don't know if you remember it from last year. It was mounted on a backing plate. So basically, we start from kind of this form factor. It's a bud box, custom milled, again, from DigiKey. And then, so a lot of our designs kind of look like this. I then designed a front plate. So sorry, probably not super visible from far away, but go to projects.goliath.io if you want to see more. But there's a custom PCB front plate with an e-paper display on it. And so that's kind of the outer shell, outer casing of this thing. And so they all kind of look the same. But then the guts are really what starts to look different. Now, pulling another board here. This kind of shows how we start from reference designs, but then we also still support reference designs. We'll talk about this in a second with the follow-along hardware. But this is basically one of the click headers that plugs into it. This is an off-the-shelf board, again, purchasable from DigiKey. And this is from a company called Microelectronica. And the reason that this is, this could be a lot smaller. It doesn't have to be this big. But the reason we do it is because we have these click boards that are pretty sizable, but they're swappable. And the swappability is really important to us because using the same form factor, we can continually swap out to different things and target different industries then. So the latest incarnation, like you said, is the Modbus sensor. And we're interested in Modbus because Modbus is a long-time industrial standard. I think it started in '79. It's pretty low, it's pretty slow, but it's very, very resilient. It's RS-485, talks over, in very harsh environments, and it talks to a lot of industrial sensors. In this case, this is a Banner QM30V2 VT2. And this thing you would usually stick on a large motor, like a big AC induction motor. And when it starts shaking around a whole bunch, something's wrong, basically. And so this has like X and Z vibration monitoring. And what Modbus allows you to do is instead of just having a single sensor reading come out of this, it's basically kind of a listing. It's basically a bunch of registers that you can go and query on this thing and say, hey, what is the X vibration? What is the Z vibration? What is the kurtosis? All these things that I honestly have no idea about. It's mechanical stuff. And so then you could pull all those readings back and start shipping this up to the cloud. Traditionally, Modbus would usually be talking to like a PLC controller, and then you would maybe attach connectivity to that PLC controller, but there's a lot of added cost and complexity. Instead, now this device is a cellular-based device using the NRF9160, talks over Modbus to this sensor, and then just ships that data up to the cloud.
Okay.
So then we can also push stuff back down to this device and say, maybe customizing it towards other devices that you plug in the future. Because it is a standard in a bus, we could plug in a different sensor here, upload new firmware to this, and it's effectively an entirely different product, right? It's not a industrial vibration monitor now. Maybe it's an industrial temperature sensor or an industrial pressure sensor. Wide range of Modbus extensions you could buy. They all have their own kind of register mapping. But once you have anyone plugged in, you say, here's the new recipe to talk to this, and away you go.
Oh, fantastic. Well, how does Golioth ensure the scalability and adaptability of its reference designs? You talked about it a bit there, but particularly for emerging IoT applications.
Well, the scalability is, on the cloud side, you think, one of these talking to one cloud instance, pretty easy, maybe even 10,000 of these. But Golioth's cloud side capabilities are kind of infinitely scalable or deployable onto different hyperscalers in enterprise situations, in our own cloud implementation. So from a scalability perspective, basically we can handle any size fleet. And then from on the device side, it's, we have a management platform that makes it very, very easy to kind of visualize and communicate with all the devices that are out there.
Okay, and Golioth has been releasing new product features on the cloud since we spoke at Embedded World in 2023.
Yeah.
Could you highlight a few that hardware and firmware developers might want to integrate into their IoT designs?
Sure. So one probably big one for the firmware folks is a unified SDK. So there's we'd had a Zephyr SDK, and we had kind of a FreeRTOS, ESP IDF, Modus Toolbox SDK. Those are all combined now. So it's all in one place. It's all one set of device-side APIs. So now when you want to call the settings service from a Espressif part or a Nordic part or an NXP part or any of the other parts that we support, it's all the same. And that really maximizes portability between projects, especially from the application code. Other things that developers probably would like, we've made a lot of updates to our ability to work in teams. So different developers working together on the same project. That's a big one as well. And probably the biggest one is we've switched from a per device model to a usage-based model.
Right.
And the reason we did that is because we've seen a lot of our users are using small sensors that are usually sending data very infrequently, and they were basically penalized for being power efficient and data efficient because they were getting these small sensors that just woke up once or twice a day. And instead now, if you have a big fleet of, say you have 10,000 sensors that are just sending a couple readings a day, your total cost is going to go down.
Okay.
And so that's been really beneficial to a lot of users that are out there.
Okay, excellent. Looking at reference designs, I noticed that Golioth, you've created a component called follow along hardware.
Yeah.
Does that change how engineers might interact with the hardware you've created?
Yes. So this is, like we kind of talked about, this is custom hardware. There's a board I probably should have brought out as well, but there's a custom board on the bottom here as well. And that is all designed from dev boards, right? So that's all started from, buying stuff on DigiKey and modifying it and kind of pushing it in my own CAD program and making it custom. But users can't buy this, maybe for the right price. But so instead, what we say is, there is this product. We open source the firmware that runs on this device. Well, that's not that useful to people. Instead, what we said is, well, actually, we can get the exact same hardware, not all of the same hardware, but effectively the same amount of hardware with the sensor we're targeting and the communication mechanism, the processing here. And so then this is the effective equivalent. You don't have the front panel, but it has the effective equivalent capabilities here. And so then the users can not only access the repository, they can download a precompiled binary that targets either this device or this device, and it's effectively the same code, the same repository. So from a getting started perspective, someone looks at this to say, that's what I need. I want a Modbus sensor. No problem. Instead, they go to the follow along hardware guide. There's a list of parts they can buy at DigiKey. There's a link to buy them all. They buy them, they plug it together, they download the binary, they load it onto this dev board, and they have the exact same thing as here. They see all the data that would be coming out of this device now coming out of this device, and then they can take that same repository, compile the code themselves, and compare it to that binary, so they make sure that they're first getting bootstrapped up quickly, and then they have the code that they can use and then modify. And so from getting started from a really known good environment, this allows users to look at something that they maybe want to have in their own design, replicate on their bench, and then go and start modifying for their needs.
Oh, okay, excellent. Well, pardon me. So we've got Golioth targeting hardware that is purchasable off the shelf on DigiKey. How does that strategy benefit your end users and the wider developer community?
Yeah, I think it's really just about getting started quickly and then knowing what's out there, right? So understanding that they're starting from the same place that the example they're looking at is starting from. And that's been one frustration of mine in the past. I go to this tutorial, I find it online, I follow all the steps perfectly, and it's like, oh, actually, you bought the B version instead of the A version. Oh, okay, well, start over, start from scratch, go compile it yourself. It's like, I can do it, but then that's added time before I see data on the screen. And really, the engineers want to see the data on the screen so that they can evaluate whether it's the right solution for them.
Well, how much would this cost to put together?
Yeah, so so in this case, cellular is not usually the most cost-effective option, right? There's usually added cost with cellular. So this one is targeting cellular. So I think it's probably close to $200 all in for the sensors for the Modbus. And then the Modbus field, all the industrial sensors, they are very pricey. So this is the most cost-effective sensor we could find. It was $300. And that's because these things are usually low volume, and they're usually targeting very high-end environments, high complexity environments like temperature ratings and things like that. So expect to be paying a little bit more for the sensors probably, but expect this thing to survive a hurricane if you need it to.
Okay. Yeah. Right. What is Golioth planning on focusing next? Are there specific areas that you would like to target, or you see an opportunity for you?
Yeah. So one of the reasons we switched to the usage-based model is we're really interested in kind of larger sensor networks and including going through gateways. So one thing we've been focusing on in 2024 is trying out Bluetooth going through gateways and targeting kind of extremely small sensors talking back through a gateway to Golioth. So a Bluetooth sensor that maybe is taking temperature and pressure somewhere usually does not have an internet connection. Usually it's talking back to a phone or something similar, or a gateway in this case. And in fact, our reference designs can also act as a gateway, or this NRF9160 DK can also act as a gateway. So it's really about reprogramming these to have that capability in them, and then collect that sensor data and forward it along to the cloud.
Okay. Now, developers, I know we've talked a lot about them, but how is Golioth supporting developers?
Yeah, I'd say that the number one thing that people point to if they're a developer, they come to our site that they like, is usually our documentation. We are well documented. Oftentimes they're finding us through things like our YouTube videos, our various blog posts about Zephyr or other ecosystems. And then we're also posting on the DigiKey forums to try and talk to the engineers that are buying this stuff and trying to get their stuff off the ground. So really, support and documentation is probably and content is the most important thing that developers talk to us about.
Okay, and if developers want to start prototyping, what should they do?
Well, usually starting with a application space is a good start, right? So kind of having a project is always a really important first step of the process, I think. And then once you're kind of within a field that you think is a good fit, I'd say go to projects.golioth.io, which is our reference design page. Just find one that's kind of close by. So maybe you're interested in asset tracking for, I don't know, electric scooter or something like that. We have one though that is CAN-based for cars, right? So it plugs in an OBD2 port with an asset tracker. It probably works for scooter as well, right? So just kind of figuring out where you are in the application space, finding something that's close by, and then probably using the follow-along hardware if it exists, or talking to us about maybe developing new reference design.
Okay. Well, speaking of reference designs, can you tell us any case studies where there's been a success, customers using your reference design, or even indeed the Modbus variation monitor?
Well, Modbus one is pretty new, so we haven't seen it. We just released this a month ago, so we haven't seen any commercial deployments of it yet, but we expect people to pick it out and use it pretty quickly. We have seen quite a few people use our reference designs, especially around the cellular side of things and the Nordic parts, and deploy those. We've seen some people use those for small sensor networks, kind of talking out to a range of sensors directly back to NRF9160, sending that data back over the cloud to Golioth, that sort of thing. We've also seen a couple of asset tracking scenarios as well, and that's been really great as well.
Okay, and lastly, your partnership with DigiKey. Obviously, you said you were posting things on DigiKey, help getting the word out, but how else does your partnership benefit your customers?
Oh, well, first and foremost, it's making sure that it's very, very easy that when someone picks up a reference design, or someone looks at a reference design, they see that they can follow along, they can go and quickly purchase those parts, they can get them next day if they want to. And then on the support and content side, we're seeing lots of support from DigiKey to help spread the word about reference designs and all the things that we can do around Zephyr and our SDK. So that's been really great as well. And generally just having the high reliability that DigiKey enables.
All right, Chris, it's been a pleasure. Thank you very much. Enjoy the rest of the conference.
Thanks so much.